Hi, I'm Matt from the Mir team at Canonical. In this first video in our series on building your very own Wayland compositor with Mir, I'll teach you how to install Mir's libraries, set up your development environment, and build a basic compositor. If you've ever wondered what it takes to write your very own Wayland compositor, then you're in the right place. You're going to get started installing and using Mir. By the end of the session, you'll have the beginnings of Compositor that you'll improve upon in the coming videos. Let's jump right in. The first thing that you'll need to do is make sure that your development environment is ready to go. I'm going to assume that you are on Ubuntu 24.04 during this tutorial, but Mir is packaged on a number of popular distros. First, you'll need a C++ compiler that supports C++20 or greater. This means either Clang version 11 or higher, or GCC version 10 or higher. Next, you'll need CMake at version 3.16 or higher. And finally, you'll need to install package config so that we can resolve Mir's libraries. And that's it. Now that you have your development environment set up, it's time to install Mir. The Mir libraries are available in the Mir Team PPA. To grab them, simply add the Mir Team PPA to your repositories. Run apt update, and then grab the libmural dev and Mir graphics drivers desktop packages. Once they're installed, you're ready to start programming. Let's start by setting up the project. First, make a new folder and call it Mirly. This will be the home of your compositor. Let's open it up in VS Code. Next, create a new file in the source subdirectory and call it main.cpp. Implement the main function in this file and print hello world, just so that you have a real program to build and run. Since we're going to use CMake to build this project, create a CMake list.txt file in the root of your project. Next, set the minimum CMake version, name the project, and set the C++ standard that you want to build with. We're going to be using C++20. Afterwards, use find package to find package config, and then use package config to find the Mural library that we installed earlier. Next, add an executable to the build, name it merely, and include the main.cpp file that you created in the list of sources. Finally, add both Mural's directories and library flags to the build. If you've done everything correctly, you should be able to build the project using CMake, run it, and see hello world in the terminal. This means that you're ready to start building your very own compositor. Let's get started with the fun part. Inside of main.cpp, include mir/log.h, Mural runner.h, Mural set window management policy.h, and Mural minimal window manager.h. Next, use Mir's logging facilities to print a nice opening message on screen. This is just so that we know everything is working. Afterwards, declare a new instance of Mir runner and pass it argc and argv. You can think of Mir runner as the engine of your compositor. It's responsible for taking the options that you provide it and constructing a Wayland server with those options. Finally, run the runner with the set window management policy option, which takes the minimal window manager as a template argument. The window management policy is a special class that defines all of your compositor's interactions with windows like sizing, minimizing, maximizing, and more. The minimal window manager provides a basic floating window policy that is common to many desktops. Later tutorials will demonstrate how you can override behavior from this policy or even write your own policy. Now we're ready to run our compositor. Mir provides a number of ways to run out of the box, but the best way to run for development purposes is nested inside of your current session. So let's start with that. First, build the project as you typically would. Next, run merely with a special Wayland display environment variable before it that will be set to Wayland 98. This environment variable tells Mir where to open its Wayland socket. Since we're hosted in another Wayland environment, the default socket will probably already be taken, which you can easily inspect by running ls on the path on screen. If a black screen shows up when you run merely, then you did everything right. Back in your terminal, run Wayland display equals Wayland 98 gedit or any other program that you like, and the program should pop up in your compositor. You can now interact with the window inside of the Compositor as if it were a regular window on your average desktop. And there you have it. Just like that, we have the beginnings of our very own Wayland Compositor. In the next video, we're going to explore how you can add key commands to open a terminal of your choice, so stay tuned for that. It will be linked in the description of this video once it's available. Thanks so much for watching, and we'll see you next time.